All right, guys. So this is part two. Well, technically this is part three. Just take a look with me real quick. So we have our PCB underneath the microscope here. This is the one with the other firmware from the defective NAND that we pulled. And I'm looking, so I put this board, I made a video. All right, let me just start from the beginning. I made a video. We got the other board working with the partially bricked firmware, okay? And so then I took the extracted firmware from the defective firmware chip from the board I got off Aliexpress and loaded it onto, where's it at? I loaded it onto this chip right here, okay? And we resoldered this chip onto the board. All right, that was the second video that you guys haven't seen. And after I did that, I went and plugged the board in and nothing happened. So we took a thermal camera to it and looked for signs of life, and there were none, which blew my mind. Now, a couple things could have happened. So either, let me just find it real quick. All right, so right here is this is the electrical connection that comes from the battery. Now, there's a small possibility that I could have unplugged it when I pulled this board out with the battery still in the unit, which is not good. That's not a thing you should do, because if you short these two sides out together, you will blow the fuse. Or either that, or where is it at? This chip right here. Either that, or there is a short underneath this chip. And what it did was it blew the fuse right here, okay? I don't know why. I have no idea. There's a chance that it could have damaged this power MOS, or this power management IC right here. Actually, let's just take this. I'm sorry, I'm just going to take this silicone pad off real quick. I'm just going to put it off to the side. And we're just going to take a look at this chip and just make sure that there's no damage to it. I do see a little bubble off to the side. Let me just make sure that's nothing we need to worry about. No, that's just goo. Okay, so the chip looks good. It looks in good shape. Where's the other pad? The other pad was right here. This is underneath the SoC, so that's nothing we need to worry about. So yeah, so I have no idea why the fuse blew. There's nothing else that we did to the board except for we put a new NAND, not new, but reprogrammed NAND on the bottom here. I don't see any solder bridges. I'm just looking for solder bridges. I don't see any solder bridges. That capacitor may be cracked. So let me pause real quick. I'm going to take a closer look at that capacitor. All right. I don't know if you guys can see it. I can see it here, but we do have a crack on this capacitor right here. On that right hand side, you see that? It looks like a crack going down it. So let me grab my multimeter real quick, and I'm going to test it for resistance and see what happens. Give me just a minute. Okay, I checked the capacitor, and it read 5.1K, so I don't think that is where the issue is. So I'm going to test to see if we have a short on the PCB. All right. It's not showing anything. Let me go switch over to ohms real quick. And we have about 200K. So that might be okay. So I'm gonna put so I have there's a couple like ground pads right here. Okay, see there's like ground pad there. There's a ground pad right there. So I'm going to put my meter on the ground pad, and I'm going to come back over here to this fuse, and I'm just going to double check and make sure that there is not a short. And it's showing about 30 meg ohm. I'll just go over to the other side. Other side is about 10 meg ohm going down. 0.7 meg ohm, so it's gone down. Still going down. Slowly going down. All right, I think that might be okay. And it's going down on the other side too, it seems. And now it's showing open. And now it went back to 40. So, I think we might be okay. So I'm going to switch right back to continuity. All right, so you hear the beep. And we're just going to check this fuse one more time. And nothing. There's my probes touching. Dead. That fuse is dead. We're going to come over here to this fuse. This is, I believe, for the card reader. So we're going to check that fuse, and you can see right away that fuse is good. And there's a little piece of schmutz right there. All right, so that fuse is good. This fuse is bad. So one of two things must have happened. Either we had the battery installed and unplugged a connector while the battery was still installed, or there's a short underneath the NAND flash. Now I don't remember if I just showed you guys. I checked the underside of the balls. Let's see, where is it at? It's right here. So we can take our microscope, and you can see from this angle, it looks pretty good. Let's go this way. So from that way, everything looks fine. I don't see any issues whatsoever. You can see all the balls look good. We'll go from this direction. See if we can focus a little better here. Everything looks good. Still no issues. And then right here, everything looks good. See if we can see anything from this side. So from this side, everything looks fine. You can see there are some components in the way, but we can still see the balls. The balls look fine. So yeah, so I think we're good. So I'm gonna go ahead and remove this fuse real quick, and we're gonna try to replace it. Now we're gonna have to protect this connector right next to the fuse, because this hot air will destroy that connector. So we're just gonna take a little bit of piece of Kapton tape, We're gonna put that down, and then we're gonna go ahead and cover up the connector. All right, connector's taped up, and we're ready to go. So I'm gonna grab a spare board and pull a fuse off of it, and then we'll pop it on this board. Okay, so unfortunately the footprint is different. The closest thing I can find is this OD device. I think that's a fuse for the display for like the little eyepiece. I don't know if the OD stands for like optical display or something, but I'm going to remove it, and then I'm also going to pull a fuse off the board, even though it's a different footprint, and we'll see if we can't make it work. So I'm going to try it, and we will see what happens. Let me take just a tiny bit of flux. I'm going to add it to this. And unfortunately, I got too much air, especially because I have a smaller nozzle on now. And you can see, of course, it's instantly burning this connector. Now this is a spare board, so I'm not very particular to this connector here. It's not going to kill me if I melt the connector. This is also lead-free solder, so it's going to take a little bit to remove. There we go. All right, so that one's free, and then we're going to come on down here. Where is it? Right there, to where it says F. Before we go through all that, though, let me just test and make sure that this fuse is still good. All right, so I got my probes, and then we're just going to... Where's it at? There it is. All right, so yep, that one's good. All right, so we're gonna go ahead and remove that one too. And we're just gonna take a little bit of flux. Boop. And we're gonna take our hot air gun. And there it is. Now this fuse is like half the size of the one on the GH5. So unfortunately, I don't think it's gonna work, but I will try my best to make it fit. And there are no connectors around here that we have to worry about, so we should be good. Where are you at? Boop. All right. So I got the two fuses off. Take a look up here. So you can see there's that OD on the bottom, and then this one labeled F right here on the ouch. That's hot. Right here on the top. I don't know if I can flip it, because when they're covered in flux, they're a pain in the butt. Oh, you bastard. So yeah. So there's our fuse, and then here's our other one. I don't know if this is a fuse too. Let's just flip it over real quick. Let's see. I mean, it looks like it could be a fuse. It could always be like a 0 ohm resistor too. I mean, I would rather have something in circuit than just like a piece of wire. But yeah, so we have these two options. I'm going to go ahead and clean the flux off these, and then we'll go ahead and remove the blown fuse on the working board. All right, it's lightning outside, so I don't know, let's see what happens. Yeah, I got the... Oops, shit, I'm gonna do it this way. You know what, here. I'm gonna move this microphone out of the way. And then we can get to it. I want to hit the fuse from the other angle so I don't get air on that. connector. I've got to be careful because there's that little resistor right next to it, and I do not want to knock that off. So it's like a stupid tight spot. Oh, baby. Don't see the solder melting yet. There we go. Okay. Chip removed. All right. Let's try to use my little angled tip here. Stupid PCB keeps tilting. I'm just gonna try to apply some leaded solder. All right, leaded solder is on. All right, now we're going to take a little bit of our solder wick here, and we're just going to remove the solder on those pads. So make sure I remove this. Come on. Oh, you stupid piece of crap. Okay, hold on. I'm gonna put this in that vise real quick if I can fit it. No, you know what? I don't know if I can fit it in there. I'm gonna try. I'll be right back. All right, no go on the vise, but I'm gonna try this and see if this works. All right, good enough. Good enough. And then it's pretty big. I don't know. We'll see. We'll see what I can do. All right, we're gonna add a little bit of solder here. So you might need to cool this down just a little bit. It's pretty hot. All right. Let's see if we can thin these pads. There we go. All right, perfect. And then we're going to take our Q-tip here, and we're just going to remove this flux here. All right. Looks good. We didn't screw up any components. There's probably a little too much solder on this side, but whatever. All right, so it looks like we can fit this little fuse chip in here. So we're gonna go ahead and give it a shot and see what we can do here. I don't know which way. I'd rather attempt this sideways, but I think I might just try it as it is. Looks like it's melting. All right. So we got it. Not my greatest work, but it is on there. Let's see, maybe we can use... Let's just put a little more flux on there. And let's see if we can't maybe push it down just a little bit. All right, whatever. Good enough. It's good enough for the girls I go out with. So I'm going to pause here, let it cool for a second, and then we'll test it and make sure we have continuity. Well, it sucks to see, but even with that Kapton tape, we still managed to kind of melt that connector there. It still works, so there's that, but it's just the price you pay. I should have put another layer of Kapton tape over it, but it's just so close to that fuse, man. So anyway, we'll clean this up a little bit better and then see what we can do. All right, now for the moment of truth. Got my probe into continuity mode. Fingers crossed. I don't even know if this fuse will work because this is for the G85. All right, well, it's good. So, all right, I'm gonna pause it here, throw it back in the camera, and see what happens. Okay, while I'm reassembling the camera, I just wanted to let you guys know that I'm viewing all the ribbon connectors just to make sure that there aren't any damaged conductors, because you never know, there could be like a shorted conductor or something. I did have that other PCB, the display on the back, that ribbon cable was having trouble plugging into it, and I kind of marred it up just a little bit trying to get it in the connector. And so I thought maybe that had something to do with it as well. So just double checking. There is a little bit of damage to this one, but it's not... I don't think it's going to affect anything. So if you see here... See if I can get it in view. So you can see the two tabs are missing on this corner right here. Let's see. So right up there. Those are missing. Got a little chewed up right there on that conductor, and then there was this little scrape across here. I don't think it broke any of the conductors because it was still working fine after I plugged it in. But yeah, I just want to make sure that I didn't leave any piece of foil in there, because if it bridges any of these two conductors, then you know it could cause a short. So just wanted to double check. And here's the mating connector, so you can see just looking inside just to make sure that there's no metal or anything inside. No chunks left behind from the connector, because that could easily cause an issue. So, but from the look of it, it looks good. I don't see anything in there, so I think we're fine. All right, so moment of truth. I double checked all the connectors. Everything was good. Power is off right now. The battery is out, so I'm going to pop a battery in here and I don't know, see what happens, man. When it blows a fuse like that, it's possible that it could have damaged the power IC, like the power controller. So who knows? I mean, at least I have a working board. It's funny that it's the one that was broken before, so we're just going back and forth at this point. But yeah, so just to double check, you know, make sure that the power is set to off. And just close this up a little bit real quick. There we go. All right, so let's get this in here. All right, that's in. Put my fingers on it. Ready? We're gonna turn it on. Nothing. Nothing at all. Just for good measure, we'll take this lens off. Put the cap back on. Try it one more time. Nope, nothing there. Let's just try one more battery real quick. Now it could be the firmware is bricked. So that could be another reason why it's not turning on. So I will give it one more shot with the thermal camera. Well, we'll check the fuse first. So we'll take the back off, we'll check the fuse, and then we'll, if the fuse is still good, then we'll check it with the thermal camera and see if that's why it's not turning on. All right, back's off of it. Can we get to the fuse from here? No, we can't. Oh yeah, we can. Okay. All right, so just double check, show you guys. So no battery in there. And we're gonna check the fuse real quick. And the fuse is still good. All right, fuse is good. So let's pop the battery in here real quick, make sure it's off again. And then we're gonna test it with the thermal camera. I'm not gonna plug it into the computer, I'm just gonna plug it into my phone and we'll look at it that way. All right, we can already see there's some, looks like there's some heat coming from inside. So it looks like the controller is trying to run. Just turn that on. See if it's getting hotter. And yeah, you can already see, sorry. You can already see the difference. So you see the ICs working, that IC up there is getting warm. These two ICs right here are getting warm. So it is running, it's trying to run. So that could mean that it is working, it's just that it could just mean that the firmware truly is bricked and it's trying to start up and run, but it's not able to run because it's not able to load the firmware. So just look at it a little closer. And if we turn it off, now it's, the weird thing is it's still warm even after I turn the power switch off, but that could just because it doesn't know how to turn itself on or off even. So we'll pop the battery out and we'll see if that makes a difference. Yeah, it looks like it's cooling down. You can see the power IC here is still warm. plug the battery in one more time. Yeah, and it comes to life. So yeah, you can see it started coming to life, but the power light is not on, and it's not going to turn on because I'm pretty sure the firmware is dead. So all right, so we learned a good amount from this. We fixed a blown fuse. Not sure why the fuse blew, but what I'm going to do next is I'm going to load the partially bunged firmware back onto this board and pop it back in and see if it works. And if it works, then we know for sure that the firmware that's on this chip is just not good. It's just dead. So anyway, guys, I'm going to pause it here and I'll catch you later.